Hello, the topic for our Learn It Yourself project is Snooping on Internet Traffic by Alhaq Dhruv Chopra, Talha Ahmed Siddiqui and Shrey Shashank. Introduction to Packet Sniffing. Packet sniffing is the act of capturing packets of data flowing across a computer network. It is also called packet snuffing, network analysis, or just packet snooping. The software or device used to do packet sniffing is called a packet sniffer. Packet sniffing has legitimate uses to monitor network performances or troubleshoot problems with network communication. However, it is also widely used by crackers to illegally gather information about networks they intend to break into. Using a packet sniffer, it is possible to capture data like passwords, IP addresses, protocols being used on the network, and other information that will help the attacker infiltrate the network. In its simple form, a packet sniffer simply captures all the packets of data that pass through a given network interface. However, if placed into promiscuous mode, the packet sniffer is also capable of capturing all packets traversing the network regardless of the destination. The packet sniffer can usually be set up in one of the two ways, unfiltered or filtered. Some of the main uses of packet sniffing are that it helps analyzing the network traffic and usage, filter content on network, reverse engineering or debug network protocols, debug network architecture, and it can also be used maliciously to spy on others. Packet sniffing can be used maliciously to detect SMTP, POP, IMAP traffic that allows intruder to read the actual email, POP, IMAP, HTTP basic telnet authentication reads passwords in clear text, SMP, NFS, FTP traffic reads files on the wire, and SQL database reads financial transaction and credit card numbers. Now moving on to Introduction to tcpdump. tcpdump is a command line packet analyzer distributed under the BSD license. It allows the user to intercept and display TCP IP and other packets being transmitted or received over a network to which the computer is attached. In those systems, tcpdump uses the libcap library to capture packets. tcpdump analyzes network behavior, performance, and applications that generate or receive network traffic. It is also possible to use tcpdump for the specific purpose of intercepting and displaying the communication of another user or a computer. The basic syntax of tcpdump command is tcpdump space option space filter expressions.
Now we'll introduce you to the basic functionality of tcpdump. tcpdump needs to be run as root because it automatically switches to promiscuous mode. We can see the various options for tcpdump using the H flag, or we can just read the manual for tcpdump. One of the most important arguments for tcpdump is the interface on which it runs. By default it runs on all the interfaces, but we can select the interface manually. Another useful command for tcpdump is the C command, C option, which selects how many packets will be displayed. Using the capital A flag, we can tell tcpdump to output the packet contents in ASCII format. Using the XX flag, we can tell tcpdump to output the content of the packet in hexadecimal and ASCII. One very important option for tcpdump is the W option, which tells tcpdump to output the captured data into a file, which is typically a .pcap file, which is a standard. We can also specify std out by using a dash as a placeholder. Now we'll show you the contents of a typical PCAP file. A PCAP file is a binary file, but we can see there is some text which is readable by the user. TCP dump is the N flag. It tells TCP dump to skip the DNS lookup. That is, it just prints the IP address of the server. Another flag for TCP dump is the TTTT flag, which tells TCP dump to print the timestamp. Part of our tutorial is about expressions. TCP dump's basic format is TCP dump, options, then expressions. Expressions are used in filtering. Some common filters are port, host, source, destination, etc. For example, port 80 is used for HTTP. We can also specify the internet protocol to use. For example, ICMP, which is used when we ping someone. For example, here we ping the 192.168.1.5 server. Here are some more examples for expressions. We can specify the protocol like ICMP, or we can specify the port. We can also specify a port range, which is in this case 1 to 100. We can also classify our expressions by source and destination. Source by SRC and destination for DST. We use similar expressions like port, internet port range, etc. We can also specify a certain host like 192.168.1.5. We can also group expressions using AND, OR and NOT. For example, here we show the packets that have the source 192.168.1.5 and use the protocol ICMP. We can further group these expressions by using brackets. These brackets have to be used with a preceding backslash. And this covers most of the basic functionality of TCP dump. Now we will show how to use TCP dump for network analysis using an example. There are three key stages required when investigating rogue traffic. The first one is traffic capture, then analysis, then identification. Our TCP dump consists of 4 packets. These 4. We first divide the traffic on the basis of port, source and destination. This enables us to deal with large amount of traffic in more manageable chunks and look for patterns. In this example, we see the first three packets are all from the 192.168.188.128 network, and from port 63793 and heading to 192.168.188.1 on various ports. This is a classic Nmap scan on UDP protocol. Now we investigate the last packet. This is because the size of the packet is very large for UDP packet, as you can see. As you can see, there is a lot of data being sent in this single UDP packet to a high port and from a high source port. This is in fact a buffer overflow being completed over UDP. For a 30-minute project, we ran tcpdump for 30 minutes and then dumped the data in a file. The general outline of a network activity was general surfing from 12:15 to 12:20, then watching a YouTube video for the next 5 minutes, then downloading a file for the next 5 minutes, then doing a FTP file transfer, then pinging a server, then SSH.
Next is Introduction to Wireshark. Wireshark is a free and open source packet analyzer. It is used for network troubleshooting analysis, software and communication protocol development, and education. Wireshark is very similar to tcpdump but has a graphical front end plus some integrated sorting and filtering options. It uses the same file format as tcpdump, that is PCAP. tcpdump is often considered better than Wireshark in certain situations due to its convenience, flexibility, and application of the user's understanding of the TCP/IP model.
This is the basic interface of Wireshark. Here you can see the interface list. We have selected the wireless interface to start recording. Here you can see the packets that were captured along with all the data on the packet. We can also specify expressions to filter the packets. Wireshark has a lot of inbuilt expressions. We can also open tcpdump files, PCAP. This is the same file as the 30-minute project. Here you can see the different data that was in this packet, such as the protocol, etc. This is the hexadecimal data of the packet. You can see when we select the appropriate bits, Wireshark automatically selects the information. Here we are filtering by ICMP, which shows all the ping packets. In statistics, we can see the summary, for example. And another is IO graphs, which draws graphs based on filters and the number of packets. For example, the first filter we choose is TCP only, and the second we can choose UDP. As you can see, this draws a graph based on the TCP and UDP traffic. We now show another graph based on ICMP filter. In a 30-minute project, we pinged a server at the end of a video. As you can see, there is a lot of ICMP traffic at the end of this capture. There are a lot of filters available in Wireshark. We can also specify new filters based on expressions and also name them according to what they do. There are a lot of options in Wireshark, in analysis and etc. This helps us in analyzing the traffic without resorting to various shell scripts and knowledge of the TCP IPnet stack.